Okay, we are recording. Hello, everyone. Thank you for joining our June edition meetup. Our online English meetup group will have Manik today present on the topic that he presented in the TDX event that happened a month ago at Salesforce when Manik attended it in person. He presented to the developer community that was present in person for the event, but today he has agreed to kind of share the same content that he shared in the TDX event with the community today. Just we were housekeeping rules, and then we'll hand over to Manik, and then he's going to present his topic today. Um, So today's topic is distributed tracing with MuleSoft APIs, and Manik will be the speaker for today. Our organizer for the online meetup English group, basically Manik and I host events in Amer, and Royston is hosting all the events for JPAC, and Angel handles EMEA. So if you have been here for the first time, this would be the organizing committee for this particular meetup group. Agenda today, just quick community meetup guidelines and community updates that we feel like you should be aware of, the distributed tracing topic, and then we'll end up the session with quick Q&A and have an open forum if you have any other topics to talk about. Guidelines, you can pop questions in the chat. There will be a Q&A section that will open up shortly, and you can post all your questions in that chat, and then anyone in the meetup group can answer, or Manik, when he pauses for questions, we can ask him those questions. Any questions that remain unanswered will be answered at the end. So if it is not in the context of the content, we'll ask it at the end of the session. The recording will be shared in our VirtualMuleys YouTube channel as well as the event page. So if you miss any of the part today, feel free to come back and look at the recording at later point. And all the feedback that you give us at the end when we send you a survey, all that matters, and we take all that feedback into consideration for the future topics and speakers so that we can get you the right speakers and the topics in the future events. Uh, Quick community updates. If you have not been to a MuleSoft event in person, we have started doing in-person meetups now. So check out any local community groups. If those groups are hosting in-person events, you can have an opportunity to network and attend a network meetup event in person. Overall, we have 150 groups worldwide. And if you want to have you join the online community group, that's the link that we have posted, where you can sign up for the future events and also RSVP for the upcoming events in June. If you want to learn more about details about the MuleSoft Mastered event, so MuleSoft Mastered is basically a webinar that will be hosted by the MuleSoft community developers and advocates. There is a link that you can sign up for this mastered event, which I'll post once I'm done with the introduction. And then you can RSVP there. The first session is going to be hosted by our MuleSoft developer advocates and a product marketing manager. But feel free to sign up for that later on. Okay, so without further ado, Manik, why don't you introduce yourself and quickly, start our session today?
Hey, sure. Thank you very much, Sandeep. Am I audible properly? Can everyone see? And I haven't started sharing, but can everyone hear me well?
I can hear you
I
fine.
hope so. Okay. Thank you. Thank you, Sandeep. So my name is Manik Magar. I'll introduce myself once we go on the slides. But before we move on there, a quick note on the MuleSoft Mastered that Sandeep was showing. In addition to all those upcoming videos and the sessions on it, also find all the TDX community featured sessions that we had at the TDX 2022. Those are also uploaded in there. So we definitely suggest you register there and take a look at all the recordings from TDX 22. So with that, let me share my screen and then I'll start with that. So, Sandeep, do you see the slide of
I can.
distributed tracing?
Yes, you can.
All right. Thank you. All right. Thank you, everyone. Thanks for joining us here. So, my name is Manik Magar. I'm a senior architect at Avia Consulting. I am also a MuleSoft ambassador and a Salesforce trailblazer. I lead this online meetup group along with Sandeep, Royston, and Angel, and also co-lead local Wilmington group here with Whitney. So there are a lot of stuff happening. If you want to reach me, you can reach out to me on Twitter at Manik Magar, or you can head on to manik.magar.me, my profile homepage, and you should see all the doors from there. Forward-looking statements, it's coming from TDX, same slides, same things. There is not really any product that I'm going to talk about. It's all the open source things that I'm going to talk about, but still whatever we talk about here, and if it ends up referencing any forward looking product, projects, anything, please consider current capabilities of everything before making any decisions about the product. So, agenda for today. We will look at the API story, how we approached that particular problem using API-led approach, what is distributed tracing, and then we'll go on to the Open Telemetry, which is a standard for the tracing. I will explain more about it, and then I'll show you some demo about MuleSoft APIs using all of these things, and then we'll head on to the question and answers. So firstly, the API story. So the use case that we are going to talk about today is our local retail store, which has been doing all their business locally only, right? So now since everything is going online, they have decided to go online too. So which means the very first use case they are looking for is their ordering platform. So they want to start accepting orders from online so that they can expand their business, right? Digital transformation for them requires some changes in their infrastructure. Some of them are like developing new APIs. They already have some of their existing APIs in their legacy platform. So not everything will be moved. It doesn't make sense probably just go out with complete migration, right? So they are going to use some of their existing APIs along with the new APIs that we will write, and then we will migrate some of the APIs into the new platform. So that's basically our use case. If we put all these things into our usual API-led approach, how will it look? Right. So it would look something like this. You have a mobile application or whatever the client that you are going to use to place your orders, which can then talk to order API, experience API, which can then go to order API, then that followed by order API and system and inventory API as a system API. So all these first four APIs are either migrated or created new. You can imagine inventory API probably was already there because the local catalog was still being maintained, right? But the order API is something new since it was always in the local, it wasn't there. In addition to that, the shipment API, they already had existing shipment API, which is in the non-MuleSoft, which is a non-MuleSoft API. So we are going to retain that API. So what we have is like four APIs developed with MuleSoft and one API, existing API, which is developed in a Java-based framework called as Quarkus. If you have not seen it, you should check that out. And then the databases for all these systems. So this is our API-led approach to solve this particular use case. It's very simple. We are not complicating it with everything that you really need for the e-commerce platform. We are going to keep it simple. Just order online in order online platform for it. So we have all these APIs. We have experience API system and everything. Then what is missing? Because just having all those APIs, I can just go online, order my stuff, and shipment API should be able to help to ship the stuff. But what is happening? So what happened in the last decade or more? Technology landscape had changed. We have a lot of new architecture styles in there. So too, we have seen monoliths, we have seen SOA, we have seen REST, microservices, other variations every 5 years. new name, new architecture styles, right? When we were working in the monolith, it was easy. One system, and whatever happens in there, you may have some visibility in there, but it was very limited to that one system only. And as we go towards the distributed applications, we have microservices and more than one application for more than one service for just one application. That is when we started having the need to understand our requests, and that to end to end, like when starting from right from the order API, let's say, until how it reaches to the last leg of your particular application on the service, right? That is the part where we started looking at the tracing as a distributed tracing in there, and the missing component for us would be distributed tracing. Distributed tracing. What is distributed tracing part? So distributed tracing, it tracks the progression of your single request as it is handled by the services which are making your application. In our case, you can think of order experience API, order system API, or order um, um, shipment API. All those APIs are the services that are making up a single application called as, let's say, online ordering application, right? Like all these services. So when we put and when we place an order, it is going to flow through all these APIs like experience, process, system, through non-Mule APIs and everywhere. So distributed tracing can enable us to see how our request is passing through all these systems and how it is being processed, what is happening with it, what are the attributes of it, basically the internals of our API, our request in there. So this is what the flow I was looking for. Order experience API. When your order comes from here, it is gonna take this particular route into your whole application. So distributed tracing is going to enable us to see how it progresses. So before we jump into how to use it and all that, let's try to understand some basic terminologies from distributed tracing, like a 101. First, a span. It is like a single operation in your end-to-end flow. If you have to put it in context, you can think of HTTP requester making and a request to the external API. That single operation can be represented as a span there. A trace, it is a directed acyclic graph of spans with parent-child relationship by definition. What that means is when order enters from our experience API and it flows through the system, the complete chain of those spans can be is a trace, and there is always a parent-child relationship between, like when order experience API creates its own span, the process API span can become its child because it's going following that chain. Attribute, just like any other attribute, it is the key value pair that we attach to span. So if we go back to our HTTP requester example, let's say the URL that we are hitting can be an attribute of that span. Tracer is responsible for creating spans. It is a framework that helps you to create all these spans, and OpenTelemetry is one of those tracer frameworks. We will see what OpenTelemetry gives us. Service, a component of the application, the one that I was referencing earlier, our order experience API, a process API, or shipment API. All those are services which are togetherly making an application. We called it as like an online ordering application, right? So one application can have more than one services in there. APM, application performance monitoring. So these are the backend softwares or the systems that helps you to visualize the data that we are capturing. For example, Dynatrace or Elastic or Splunk, all these products which can ingest all these tracing data that we are capturing from our system and help us to visualize in a more human-friendly format so that you can understand the internals of your systems, right? So these are the bare minimal keywords or the terminologies which you should know. There is more than this, but I think this one should help us to understand tracing in our context. So what do we need? If we have to enable tracing, what do we need? First of all, we need an instrumented library or application that is being traced. In our case, that would be all our APIs, right? So we want to trace all our APIs. We want to collect data from our APIs. Then a tracer to generate spans. So tracer, like I said, it is a framework which helps you to generate all these spans or color or generate this data. So for example, OpenTelemetry. OpenTelemetry is a framework which helps you or do all these things. We will learn more about OpenTelemetry in subsequent slides. But for now, we need a tracer to generate our spans. Then we need APM to collect and visualize traces. It could be Elastic, it could be Dynatrace, Splunk, like any APM software that is available out. Right? Lastly, we need an APM aware span exporter. What does that mean is when we export spans or when we export the data about our application requests, we are going to send them to a third party application, right? Like a software. Let's say we start sending all these to Elastic, then we need to send all this data in a format that Elastic should understand. Or if we are talking about Splunk or Dynatrace, whatever tools we use, that APM aware span data we need to expose, the format needs to be there. And just if you recall the number of APM products I named, Dynatrace, Splunk, Elastic, New Relic, probably there are a bunch more, right? So if we start using something APM aware, we can easily get into a vendor locking, wherein like, okay, we have like 10 applications and we are exporting data in a format that only Elastic understands. Tomorrow we want to move away from Elastic to something else. It's a rewrite because we were talking very specific about Elastic, right? So if everybody is processing this span data, everybody is processing this trace data, isn't there any common standard which can help us to avoid this vendor locking or help us to speak a vendor independent language in there, vendor agnostic language? And there is that such kind of framework. And that framework is nothing but an open telemetry. So this is a definition from Open Telemetry's documentation. Open Telemetry is a set of APIs, SDKs, tooling, and integrations that are designed for the creation and the management of telemetry data, such as traces, metrics, and logs. Obviously, you can read that definition on the Open Telemetry docs too. But that is the part, like Open Telemetry as a standard in the CNCF Foundation, they have a standard set of APIs, data formats, SDKs that you can work with. And when other APMs, for example, Elastic, Dynatrace, and all those APMs, if they are compatible with OpenTelemetry standards, then there is now a common layer between your application and those APM products, which is vendor agnostic. Now your applications will speak in the language defined by OpenTelemetry, right? So tomorrow they are not directly speaking about Elastic or any other format. So it's all a standard language or the standard data formats. Why OpenTelemetry? Some of the reasons, there are more reasons, but these are some common things. Like I said, it's a vendor agnostic instrumentation. You are exporting data in a specific in a format specified by OpenTelemetry specification. OpenTelemetry semantic conventions for vendor agnostic data collections, which means when you are, let's say, when you are exporting a data about an HTTP requester, you add an attribute HTTP request URL. So the name of that attribute is vendor agnostic. Maybe vendor A calls it something else, vendor B something else, but you are always exporting the same data attributes. If they are compatible, they will adapt to that and they will process your data according to their specification, right? So it supports multiple projects. It is not specifically for Java. They have a tools and frameworks and SDKs for multiple languages, which means if you have APIs or if you have applications not in Java, some other languages, you can just pull the SDKs appropriately and enable tracing on those applications too. You have multiple languages support, and The control what data and where it is sent. The last part is important. So when you are collecting orders data, or let's say you are collecting information about your payment system, it is obviously there is some data that you may not want to send to your APMs, right? So OpenTelemetry then also supports you to add processors which can then process your data before it gets shipped out to the APM system. So you get to control what data you are sending and where you are sending all of that. So these are some highlights about OpenTelemetry. More you can see on the OpenTelemetry.io docs. There are so many reasons about why OpenTelemetry. So now, if we put all this OpenTelemetry back into our API-led approach, how would it look? There is no change in the API-led part of it. So our APIs are same. They are being invoked similarly. The only difference that now we will see here is all our APIs, including the Mule and the non-Mule APIs, all are now exporting and OpenTelemetry data to OpenTelemetry collector. Collector is a component in OpenTelemetry, which is basically receiving all the OpenTelemetry data, and then you can configure collector to send that data to any backend vendor. Like here example, I'm showing Elastic as a backend APM. You can put any APM here. If it is compatible directly with the OpenTelemetry specs, you can just push that data. If not, most likely those vendors will also have OpenTelemetry exporters, which can convert the OpenTelemetry data into their format before sending into those APMs. So that completely separates your applications from any APM vendors. So now we see this thing. We have the API-led approach. We have our APIs. We have something called as OpenTelemetry collector. But how do we implement this in Mule APIs, right? Like how do we do actually in the code? So let me introduce you to this thing, Mule OpenTelemetry module. So this module is developed by Avio. It is developed by us. It is custom module developed using the Mule SDK. It is completely open source module. You can go to this github.com/avioconsulting/Mule OpenTelemetry module to see the code and everything around it. But some highlights from that module is it is fully compliant with OpenTelemetry's semantic attribute conventions. What does that mean is the data exported by this module is fully compliant with what OpenTelemetry is asking for. That means any OpenTelemetry compliant APM like Elastic and all other stuff, they should be able to consume the data exported by this module. So it supports OTLP, which is OpenTelemetry protocol, and other exporters, which includes if you are exporting data to Zipkin, you can configure it to use Zipkin exporter, and all your data will be exported into Zipkin format. Then you can ship that data to Zipkin. If you are exporting some other formats, there are these exporters are provided by OpenTelemetry framework. If you go on OpenTelemetry site and look for different exporters available, you will probably find exporters for most of the APM providers. Right? It does support trace context propagation for distributed transactions. What that means is if I go back here, when a transaction starts at this API, it is getting propagated to throughout your application so that we can bind that spans across our services, and we can create one whole trace for all our service applications, right? So it does supports that. In addition to all this, we also have a Cloud Hub aware Mule resource provider. What that means is if you deploy your application in Cloud Hub and this module is in there, it will automatically start publishing the details about your environments. For example, the environment name, which worker it is running on. So basically, you can see the request is going to which worker or how it is being processed inside the Cloud Hub in there too. Right? Like I mentioned earlier, it supports OpenTelemetry compliant backend APM. So as long as you have that, you should be fine. It is least intrusive to your application, which is a good thing because you don't have to rewrite whole your application, and I'll show you the minimal configuration that you need to enable it, right? So with that, let's go into demo. But before heading into demo, Sandeep, are there any questions that we want to take before we head on to demo?
No questions yet, Manik.
Okay, so let's take a look at it. I'm gonna stop the share and share the whole screen so I can show you. Okay. Okay, do you see a studio?
Yes, we can.
Okay, is it readable?
It is for me. Yes.
Okay, so if I go to, so this is module, right? It is published to the Maven Central, so you can just copy this dependency here and use it. How to use it? Let's take a look at it. So I have 4 APIs here. The one that I used for the for that use case: inventory, order experience, process, and system. How do we use this module? The very first thing, add a dependency to that module, and I think I have it here somewhere. Yeah, here, right? Dependency Mule Open Telemetry module 100 Mule plugin. As soon as you add that, you then get a new module here, Open Telemetry. It has only one operation, and the reason for that, like I said, it's a least intrusive. There is not much you have to rewrite for your application. So then the next thing we do is we add a global element to configure our OpenTelemetry module. In the configuration, at the minimum, what it needs is where is your backend APM, basically that OpenTelemetry collector. Where is that running? Where do you want this application to send your trace data, right? So that means we will configure a collector endpoint where our collector is running. And then if it requires any additional headers, for example, most likely all your APMs will require some kind of token or some authorization mechanism to authenticate all your data, right? So you would do that here. In my case, I'm going to use Elastic as my APM, and then Elastic has its own collector running in there. It requires a bearer token, so I'm configuring my bearer token in here header. So I have endpoint, I have auth token. Then I have something at the resource level. What this means is I have four applications running, right? How do I identify each application? So I will configure that here. So for example, when I'm in order experience API, my service name is coming out as a domain, which if you are running in the Cloud Hub, it is auto-populated by Cloud Hub. But if not, you can put that in the properties file or anywhere. So basically, this value will identify this service name. And in addition to that, then you can add more attributes, for example, Mule environment or deployment, whatever the additional information that you want to add for your application, for your service level. You can add that attributes here, right? So literally, these 4 things should get you configured and running. And if I switch to XML here, you will probably get to see what. So this guy, this is, oh, sorry. So this is our OpenTelemetry's module configuration. You can see I only configured the collector endpoint, authorization, and some attributes that I want to assign to my resource. So that's the only configuration you require. You don't need anything else to start capturing your data. That is one thing, right? Now, the second part, when we have, let me go back here. So when we are sending that data, as when we receive a request and it starts moving through all these processors. Now the module is configured, it will start working behind the scene and it will start capturing data as your request proceeds through each of these operations, which means you're not making any change to individual operations. Those operations are completely what they were before introducing this module. So it's like if you want to remove this module, the only thing you will do is remove the dependency, remove your global configuration, and you are done from there, right? So that's how you configure the module. Now the module is configured. What happens with that? What change is it going to make, right? So let's take a look at the applications I have deployed on the Cloud Hub. Let's see. So I'm in this demo. So I have these applications deployed here: Order Sys API, Experience API, Process API, and System API, Inventory API. These applications are having, so I have this endpoint here. This is Experience API, right? Experience API, and I'm going to post an order to that API. So I have this post body. Right? This is my post body, and I'm going to post an order. I receive an order ID and I see 202 accepted. So because we have any point MQ in between, it's not really created with this one, it is just accepted. I'm not going to go into applications here because you all probably already know how Mule works in there and what is happening. Let's take a look at the trace data that got captured, right? As soon as it received that request, we will switch back to Elastic here and here. So I have Elastic configured here. All my trace data from all my from 4 applications is being sent to Elastic, which means I'm using Elastic as my collector. So you can see here I have a trace called /API/star. It is coming from this guy. So I have Experience API, the first entry point. This is my first entry point, right? This is where the request arrived. Come on, show me here. Okay, so here. So this is where the request arrived when I sent it from Postman. So this is the starting point of our trace, right? So this is our very super parent of that trace. And this is the path. That's why we see this path in our trace. So this is the trace. So if we go in there, scroll down a little bit. So I'll zoom in a little bit, zoom out a little bit so we can see. So now, because of that module, what do we have here? We have a full end-to-end trace for our API, for our order creation, which is starting as /API star. And if we look at this thing, API router, post to the other one, then submit order workflow and all these things. If you have seen the Mule application, you can easily imagine we have listener, it's going to the router. From router, it is going to this post order flow. From there, it is going to the submit order flow. Maybe if I just do like this. So we have API. This is our post order flow. Then it is going into submit order flow. And if I keep going into that, so this is, it just started rainbow spinning. Okay. So then here you have a set variable logging, another log, and then finally it is publishing to the MQ. So here we see order process in MQ. And if we look at this any point MQ, that should be the destination it is publishing to. Yeah, here, order process in queue. So what that means is just because we added that module, we started seeing the trace and the spans created for each of these processors, right? And if we send all this data to the any APM, the APM is going to help us visualize, which means this view of our traces. So this is where we received the first span. We sent it to any point MQ. Then from any point MQ, our second process API, which was listening to that any point MQ, here it picked it up, order process in queue process, right? So then it, so order processing process API picked it up using the anypoint MQ. It did its processing and then it called the get inventory flow. Get inventory subflow ended up posting a request to inventory system API. So this is where our third new system, new service started, like Avio OBS inventory system API. So inventory system API continued, and at the end, it again it came back and it started creating the order in our order sys API. So this is where our order sys API started, sys API. Right? If we keep going down, we see DB order creation, the database operations. So this is where the database insertion is happening. Insert into test DB orders, order ID values, the SQL that was used for it, right? And I'll show you the attributes, but just let's look at the flow, the complete flow. So order was inserted into database. Once order is inserted, then it called the create shipment flow, which is sending our request to a shipment API, this guy. And shipment API, if you recall our API-led approach diagram, shipment API is a non-Mule API. It is running in Quarkus in my different cloud. So it's a Java service, right? So it went in there. So we also have the traces from that non-Mule shipment API because I have enabled um, OpenTelemetry, OpenTelemetry configuration in that too. That is not using the Mule OpenTelemetry module, but the Quarkus has inbuilt support for OpenTelemetry, so I enabled it there. With that, we can see the shipment API is then again calling our inventory, right? So what that shows us is we have a complete end-to-end trace for our single order, and it is going across all these systems: experience, process, system, and then shipment API, and we see 202. What about the attributes? So if we look at any request here and look at the metadata for it, we can see a lot of information about our own request, like the route on which it arrived, right? And when I was talking about the Cloud Hub Aware resource provider, these attributes about the Mule environments are by default exported by the module because it realized that, yeah, I'm deployed in the Cloud Hub, so let me just grab more information about your environment. So you have environment ID, your region, type of the environment, and all other stuff, right? What happens when request fails, right? So let's go back and let's send a bad request in here. So I have a validation failure here, the quantity 0. Nobody should order anything with a quantity 0, right? So I get bad request and 400. So if we go back in there and take a look at, I think I'll refresh here. Yeah, this one. So our request failed, 400 bad request. But why it failed? Now, if we just go on view related errors here, it should show us why it failed. Okay, here's the error. Order quantity 0, not 0 is not greater than or equal, which means the order quantity should not be 0. And that's our exception. Right? That's our whole exception with the details. So any failures or any errors that are also exposed. Now, when I said let's click on this red thing here, like click on the view related. So this is a feature of the APM. So Elastic has a presentation this way. Other APMs may present it differently, but the point here is all these error details and everything is exported by that module. So that enables any APM provider to show you all that data. So you can visualize the data, you can see what is happening in your system and how systems are interacting with each other, right? So that's the error scenario in there. Um, Other than that, let's see what else we have. So this is all the trace data. What happens to the logs, right? Obviously, logging is not part of this module. It is purely just for the tracing. But if we take a step back and say, okay, I have traces. If you think about the observability, which also then includes metrics and logs, right? So this data here, which is a trace data, has a trace ID and everything. If you extend all these things and start sending your log data to Elastic, it should be easy to correlate both the data like trace data and log data. I think I have an example here. So if I go to a particular trace, so this is one trace from the past when applications were running in the local. Same example, it is going through everything and there are errors, all these things. But at that time, I had Logstash pipeline running and posting all my logs to Elastic2. And the moment I do that, since the trace IDs are connected, now I am on this particular request with trace. If I switch to logs, it is going to show me all the logs related to that particular order processing, that particular request, right? So it is not only giving you insight into your request with the trace data. If you enable logs in your observability stack, you should be able to tie them together and create a complete view of your request response processing in there. I think that's in there. Let me see if I have anything in here more. I'm gonna go back to my 5-minute thing. Right. Okay, so these are getting created again and again. The other part I think it can enable you is search by the request attribute. So if I go here and if I just want to search something, HTTP response code is equal to 201. I don't have for this cycle, but if I do last 30 days, yeah. So I can basically query all the data attributes that are being captured. You can query by the status code, you can query by labels, and basically if you look at these things, you can query by anything. You can query by flow name to basically everything. Uh, something interesting here is service map. This is a feature of Elastic probably, and every APM may present it differently. But since we have all that transactional data, it can show you how your systems are talking to each other. So Experience API is going to the Orders Process API. I need to refresh. Oh, I have something local too. Last 15 minutes. Okay, so now you can see Experience API is going to Process API, which is talking to these two systems API, and then finally going to the Inventory System API too. You have Anypoint MQ here, you have database here, so you can drill down into your dependencies and find more data. It can continue because now that we have a ton of data about our applications, we can just look for different graphs, different visualization patterns, or anything to learn more about our own applications, right? So that's the part I wanted to show. Just a quick recap. We have a module that you can easily configure in your application by adding a dependency here, then configuring a global configuration for OpenTelemetry config, and pointing it to whatever the OpenTelemetry collector you are using. If you are using Elastic, point it to the Elastic's collector endpoint. All that you should be able to get it from your APM's documentation. Authorization endpoint and the information about your service, right? Once that is done, just run your applications normally and model will start collecting data behind the scene.
Hey Manik,
So yeah,
yeah,
good.
great demo, Manik. We do have some questions if you're open to it now.
Yeah, go ahead, please.
10 minutes more, yeah. So yeah, the first question is from Higavit about how much overhead it will add when we enable this collector on any API.
So the processing is purely done by the notifications. Is based on the notifications that are already generated in the Mule runtime, right? So every whatever when some an event happens or a processor processes something, Mule runtime is raising those notifications, and we are tagging along on those notifications to create all these events. There will be some impact, so we are in the process of running the whole performance test to understand it, but it is not it is same as you enabling the any point monitoring on your application, so it should be few percent but not more like a great thing there.
Okay, thanks,
I,
Manik.
I mean, I know I don't think I gave a hard number in there. For example, any point monitoring says if you enable this up to 4 or 5%, I think you will see a CPU usage in there. So this one should be around the same time since it is not generating any new events or anything.
Yeah, is there any place, Manik, where you would publish this results once you do the analysis?
Yes, it will be same back on to the. It should come back to our GitHub. This GitHub module, since it is open source, all the documentation and everything is on our repo, right? So at some point you can expect to have sections here showing what we seen in that results, but it should come back to this documentation. And the, with that, I can also say this: for any additional information about the module, how to use it, what to do in there, you can refer to this documentation. It has examples in there, it has configuration details. And if you look into the module, there is for examples here, which you can refer and see how things are configured and how they are used.
Okay, great. Manik, thanks for that. So next question is, in the custom module, how to configure attributes for a span? Does it include metrics too?
No, it doesn't include metrics. So there are three things in the observability, right? Tracing, logs, and metrics. So this thing is only for tracing. It doesn't include metrics. It doesn't include logs. At least at this point of time, OpenTelemetry as a specification does support, does define logs and the metrics in there, but it is not implemented yet for this module.
Okay. Hope that
Is
answers
that?
your question, Thiago. Yep. Next
Yeah.
question is from Juan. Can we correlate two APIs connected with Amazon SQS without HTTP request or listener using the same correlation ID?
We can. So, I mean, it depends because your other side also need to support that context propagation, right? Like, for example, if I go back to our example, we have our experience API and process APIs are communicating over any point MQ. So experience APIs is sending that order, publishing that on any point MQ, and this guy is listening. Now, any point MQ, we have propagated that context using the any point MQ's properties method. And then on the other side, since we are using the same module, it knows how to read it. So you can send that context to SQS, but on the other side, if it is understanding the open telemetry, then it should work. But if the other side is not understanding the context from the open telemetry, probably it will just go unused. So I would say you can try exposing that context to your SQS and see on the other side what you receive. Right?
Okay. Thanks,
But
Juan.
yeah,
Juan, if you have any follow-up questions, post it in the chat. Manik, you were saying something?
no, I was just gonna say like, but the point I was going towards was we do support the context propagation. So you have everything available in your variables to do any custom propagation. If you have a processor that is not supported out of the box, but you know a way to propagate your OpenTelemetry context, you can easily use a variable which is there in the context propagation in these documents, and you can set that on there, and it will just go with it. You have to just make sure on the other side it understands.
Great. Okay. So next question is again from Iga. How does the Mule native logger behave when using this connector?
Mule native logger is completely different. I mean, I don't think it is connected for this module. That is just another processor. So if you see these things, you see the logging here also, like a log. Just it is captured as another processor, right? And this might look like a lot of noise. Like most likely, if you do a real tracing and if you are really interested in data, you may want to ignore all these log variables, set variables, because they don't, that might just look like a noise. So what you can also do is like go on your configuration, and at the bottom it has span all processor. If you turn this off, it will exclude all those common processors like set variables, logs, transforms. So it will only capture where you have interactions with external systems. So in here, you will see HTTP listener in, any point MQ out, any point MQ in, HTTP out, HTTP in. So it just reduces the noise from it and gives you a more clearer picture of how you're interacting with external systems. But for logger part of it, it is no different than any other processor for this module. Does that help? Hopefully.
Yeah, hopefully it helps. Next question is from Justin. Are spans sent synchronously to Elastic, or are they stored in an in-memory queue?
So spans, first question, are they sent asynchronously? Yes. The whole OpenTelemetry SDK and SDK works behind the scene, and it is asynchronous to all your processing. So none of that is going to block any of your current processing. Since it is driven by the notifications of Mule runtime, the notification itself are asynchronous, right? Like they don't stop your events. So it is asynchronous. Second, the spans generation and transfer is handled by SDK, and it keeps in memory, and it continuously flushes that out every few seconds. It is configurable. If you look at the OpenTelemetry documentation, you can control and tweak everything of it. Like, oh, I don't want to send data to Elastic for 1 minute. You can configure it that way. Like every 1 minute it will start sending data. I want every 10 seconds. You can configure that also. So it is fully configurable, and it honors every configuration defined by OpenTelemetry SDK. You can do all that configuration to control how it is behaving.
So there is another question from Justin. Does the connector expose a sampling rate such that you would only send spans for 1% of the successful request and send spans for all the failed requests? Can you control that in the connector?
So that one will come as a part of OpenTelemetry's sampling and processors. So that part, if we go more deeper into understanding how OpenTelemetry is, OpenTelemetry has multiple components like an exporter, processor, collector, sampler. So the one that Justin is asking will fall into collector side of it. So in collector, you have an ability to define your sampling intervals. You have a capability to define your samplers, like what kind of data you want to send, 1%, 2%, all that stuff. That is outside of this module. It is for Elastic. The collector is provided by Elastic, but there are APMs which doesn't provide that. In that case, you will apply all this sampling in the collector level, not in the module level.
Thanks, Manik.
Yeah.
Is there any additional configuration? Next question is from Higa. Is there any additional configuration that you should be done to avoid synchronous logging? Uh, so that he guys doing a POC, and the Mule logger was printing the event for them. So, is there any recommendation there?
I, I mean that's unrelated to this module, but I would say Log4j2, if you are using async loggers there, that shouldn't do synchronous logging. Maybe the logger is not configured properly to use async logger, and it is using the sync loggers. That's not related to the module or this stuff, but that's the only thing I can think of. It shouldn't do synchronous logging.
Got it. Okay. So next question is from Nisarg. Do we need to add any custom header on HTTP requests from the Mule app?
HTTP request, okay, yes. So the part where we are propagating, right, like here. So get inventory flow. So if we go back, let's look at our process API. That's a good question. I should have shown this earlier too. Here, create shipment API. So context propagation that I was referring to, come on, settings here, right? So at the request configuration level, to enable that context propagation between the APIs, we need to add this trace parent variable with the variable I was referring to. Trace parent is equal to where's hotel trace context dot trace parent. When implementing, we don't need to know what is in there. This whole thing is exposed by the module. So when you do this mapping, it will start propagating this context to any HTTP requesters. And this links back to the SQS question too. If you have an SQS connector or basically any connector where you know if in SQS properties, if you add this trace parent, SQS will honor the Open Telemetry. Then you can just go ahead and set this variable into SQS properties too. So this is what I'm doing for the HTTP request properties. Same thing you can do for any point MQ. So basically, it allows you to configure your context propagation to any supported connector or any supported processors in there. I hope that answers the question because that's the header that we need to add in there.
Yep. Yes, it does. Thanks, Manik.
Yeah.
Let me see which other. Can we send it to Splunk and push to Elastic without using Mule anypoint monitoring? I don't understand what the question, but does that make
Yeah, I
sense?
mean, I will split that question. First, we are not using any point monitoring anywhere here. Okay, so any point monitoring is not in the picture in this particular solution. Let's keep that aside. Second, can it be sent to Splunk? Yes, you can send it to Splunk because, like I said, we are talking about Open Telemetry, right? If I go back to here and if I have a collector for my Splunk, I can just configure that endpoint here and provide the authorization to that endpoint. And the same data that was being sent to Elastic will start being sent to that Splunk collector, right? And then you can inject that in, you can basically whatever then Splunk will support ingesting that data, you can do that. But from export point of view, you can send it to any Open Telemetry compliant collector endpoint.
Thanks, Manik.
Mhm.
The next question is this module compatible with Json Logger?
I don't think there is any compatibility in between that because if you drop a JSON logger, for example, if I go back to my example here, we have our another open source module called as Mule Custom Logger, which is similar to JSON Logger if you say so, but it is based on Java and it has a lot of different things. Uh, just like the previous question about the Mule Logger, it will be just another processor for this module. No difference. It doesn't need any compatibility. It doesn't make any difference when the module starts capturing the data, it will look at this logger just as a processor and it will create a span for it. unless you disable that span all processor part. But you don't need any compatibility for any of the processors. And that's the part I was going towards when I said least intrusive to your application, right? If we really think about the changes, we added the dependency in form, we created a global configuration there, and if we are sending out to HTTP requester, we add that header. If we are sending out to the any point MQ, we add that as a property. That is all at the global config level. No, none of your actual flows have been modified. So all these flows are completely pure as if they will be without that module. Right?
Thanks, Manika. And I think we are up on time. There's one more last question that we can address, and then we can close out for today. Uh,
Sure.
must the support be added on per connector basis? Is there any support provided by Avio? How is this product supported?
So if we look at the documentation right now, we have it's an open source. First of all, it's an open source, right? So feel free to uh, send pull request and everything. That's open source in there. But to begin with, we have the support for these three things and HTTP listener request database connector, anypoint, MQ, flows and everything. When I say that, I want to make it clear that it will support every processor, right? The only difference is when a known connector is found by the module, it will capture more data than capturing for a generic processor, right? If you drop in an SQS, it will still capture the data about the SQS, but it may not know what are the other attributes of the SQS. We are going to add more and more support. So I think the next one in our queue is enable support for the JMS connector, so we will keep adding support for more and more connectors, I would say there.
Okay, great. Thank you,
If, if
Manik.
you if, if
There
you
is
have
one
like
more,
any specific,
there,
sorry.
there is one more question from Murli.
Sure.
It was in general. So, uh,
Mhm.
is there a way to suppress the security headers? Looks like it is passing all the HTTP headers in the trace. Uh,
It can be, but again, that will again go into your collector from the HTTP, Open Telemetry processor component point of view. So if you look at the collector configuration or the collector architecture, you will find their capabilities to add processors, to find their capabilities to add sampling. You would do all these things at collector level because now when I said we are open telemetry compliant there, we followed all the specifications and guideline provided by open telemetry, and with that guideline all these processing of the data should fall into processor, into the open telemetry, into the collector. So you won't be able to do that in the module here, but you will be doing that at the collector level by configuring your processors. And
awesome.
if I may just quickly
Sure,
show
sure.
this thing, if you go into this module and take a look at the SRC test Docker, there's a documentation if you want to test the Zipkin. But the part that I want to show here is uh, this is a very minimal and simple OpenTelemetry configuration file, right? Which is for my test Zipkin testing in my local. But here you can see when I'm configuring my collector, it allows me to configure receiver, processor, and exporter. So receiver is where we are sending the data from our module. Then in chain comes the processor. This is where you will process, massage, whatever you want to do with the data, sampling and everything. You will do it here before the data gets really exported to your final destination like Elastic, Zipkin, or anything. So all those questions about sampling, pre-processing, and all that will be part of the collector in here.
Okay.
Right?
I think that is all the questions, Manik. Any closeout thoughts from yourself?
No, I think it's very interesting when you see the data about your application. So I would definitely say go ahead and give it a try. It's open source. All the documentation are here. Try it out. for any questions or issues or anything. You have GitHub to raise issues and let us know for any feedback on that one. So thank you for listening and having me here, Sandeep.
Thank you all, and just for everyone, we'll be posting the recording and the presentation on the event page in another 24 hours. So feel free to check it out if you have missed any part today. Have a good rest of your day today. Thank you, everyone. Bye.
Thank you, everyone. Thanks.